Awesome Griffin's occasional series of YouTube tutorials. Today we're doing the independent t-test in Excel. And just to give you some historical perspective, W.S. Gossett, that was his real name. He worked for Guinness in Dublin, and he had to use a nom de plume of student T because Guinness owned the intellectual property of the work that he carried out. So when would you use this? So you would have an independent and a dependent variable. So in this example here where we're highlighting at the moment, we'll be looking at salaries 1 year after graduation. So if you're a mechanical engineer, you're looking at the salaries after 1 year, and the differentiator is gender. So the independent variable, the thing that you think might cause influence or might determine the outcome, would be gender, male, female. And I took that example from there. There are some assumptions. Your dependent variable, your salary, is continuous. And then assumption 2, that there's 2 categories. Male, female, yes, no, took the drug, took the placebo, etc. Number 3, just get my mouse, number 3, there we are. Independence of observation. So just, nearly any lecture trying to explain that concept would say tossing a coin. When you flip a coin, the outcome on the second flip has no bearing on the outcome of the third flip. No significant outliers, so there's nothing really mad. Like say you're doing student IQ and there was nothing really mad. Like you had an IQ of 200, which would be a typo. And even if there was a student type who had an IQ of 200 and it was a small sample, that could, adversely affect the outcome. This one here, number 5, your dependent variable should be approximately normally distributed. There's a test for that, Kolganov-Smirnov, and I have that done on my YouTube channel. And number 6, for this one here, we assume that the variances of the 2 groups are equal, and there's 2 ways of doing this, and the one that I mentioned there is the F-test. Just one thing to mention, one-tailed or two-tailed test. So if it's one-tailed, we're here, it's usually the 5% level of significance is either in the right-tailed or the left-tailed, or the more usual case, but it probably is, where it's a two-tailed. So you have a level of significance of 5% and there's a rejection region of 2.5% there, or 2.5% in the left tail. Okay, I assume you know this. There's the processes that are the stages that we go through. So we'll have a look at that now in a sec. So here's an example, and you had 2 groups. One group took caffeine and the other group took a placebo capsule. And what you did was, just get my mouse up again, there we are. You measured their RER, their respiratory exchange ratio. Okay, and so you just want to see, did caffeine or no caffeine have an effect on them? Okay, and I took that example from there. There's a screenshot of the data used. We typed this up in Excel. And in this one here, there's 2 possible two possible outcomes. We mentioned before we could have a two-tailed test or a one-tailed test. So if it was a two-tailed, we could say caffeine has no effect on RER, so that has no effect, that it would increase RER or lower RER, or we could have a one-tailed test. We could say caffeine reduces RER, or for that matter, caffeine increases RER. We're going to do a two-tailed test. I've gone through the 6 stages that I listed above. So the dependent variable is the RER and the independent variable is the caffeine. So the caffeine, we think, is the thing that causes the effect, the outcome. And the RER is the thing that's dependent. Null hypothesis here, and we're going to go with a two-tailed, no effect. It's a student t-test. And why is it a student t-test? Because there's a small number and they're approximately normally distributed. We're assuming that, and we're assuming that the variances are the same. We can do a test later on in another Excel video to show how to do the f-test. The critical values I looked up before, but we'll explain how we get that from Excel, and then we'll see what happens. So let's just go out to Excel here. Just go up. There's our bit of data, and our data analysis there. Now, this might not be there on your home machine, so just to check that it is there, you go Excel options, add-ins, manage Excel add-ins, go, and then just check that these lads are here. Now obviously we don't need them all, but we put everything in. So you need the analysis tool back just to make sure that you can run the test. So there's our data analysis. We're doing the independent and we're assuming equal variances. Click OK. I've done this before. So the placebo effect is there. Doesn't matter which is which. We can leave that blank, or if we're assuming that there is no difference, if you want to be precise, we can put in 0. But same thing. And we're going to put the results into a new worksheet. So let's do that. So let's widen that a sec. Let's make the font a bit bigger. So just to make sure, if you're looking at this, we'll widen that again. We've computed the t-stat 1.999 and the critical value for the two-tailed test is 2.119. So if I just go back to here, that's minus 2.119. That's plus 2.119. So if our computed t-value lies between there and there, we accept a null hypothesis. Sorry, we have no reason to reject a null hypothesis, to be precise. So if we're between minus 2.119 and plus 2.119, we have no reason to reject HO. So let's just go back again. Yeah, our computed t is minus 1.994. I'm sorry for flicking now. Minus 1.994 is just there, and that's in the we have no reason to reject HO. We also get, where did I get this from? The 0.063, sorry for flicking there. The 0.063 is there. So this is another way of saying, remember the level of significance was 5%, 2.5 on the left and 2.5 on the right. So in effect, if we got an answer in cell B13 of 0.05 or less, we would have reason to reject a null hypothesis. But we just scraped over the line. We got a 6.33%. So that's a further reason to say we have no reason to reject HO. Okay, so hope that helps. Thanks very much for listening.